Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for June 13th of 2025 is titled Rubin's Galaxy. So what do we see here? Well, here we see a tremendously large spiral galaxy. And of course, you can't just tell that from the image because there's no perspective here. But this is about 800,000 light years across. Now, to put that in perspective, our Milky Way, a decent-sized spiral galaxy, is about 100,000 light years across. So 8 times the size of our own Milky Way. Now, the galaxy is known by its catalog designation of UGC 2885, also known as Rubin's Galaxy for astronomer Vera Rubin, who did a lot of studies on spiral galaxies. And what we see when we look at the galaxy here is the distinct structure we're used to seeing with the spiral galaxy. We see a central core. We see that it has a disc-like structure with arms swirling around out from the center. Within the arms, we see lots of dark dust lanes. And further out, we see a lot of blue star clusters. And those are very young blue star clusters forming within the spiral arms. Now, those are all things that are associated with typical spiral galaxies, but this one is much larger. So one of the reasons to study this galaxy specifically, is try to understand how some spiral galaxies can grow to such tremendous sizes. Now, Vera Rubin is also very well known, not only for her study of spiral galaxies, but for using those to get the first evidence of dark matter. And what was studied was the rotation of stars within the galaxy. So what would be expected is, as you look at stars as you get out towards the outer edges of the galaxy, they should slow down. They should be moving slower and slower. And that's because they're getting farther away from most of the mass and their velocities would slow down. We see that in our own solar system. Most of the mass in the solar system is in our sun, so material will then move faster when closer to the sun and slower when farther away. And we can see that just in the planetary orbits. But what was found with spiral galaxies, and not just this one, but essentially all spiral galaxies, is that those stars at the very edge of the galaxy are not moving slower as we would expect, but they're moving faster. And one way to explain that is by using dark matter. Dark matter is very unusual. It's a mysterious type of matter, and it doesn't interact except through the gravitational force. And that way there's no way to detect it directly. So it essentially surrounds everything, but it doesn't give off any light, hence its name of dark matter. And it doesn't have any other way to detect it. So not just visible light, but it doesn't give off anything. X-rays, gamma rays, any type of light is not emitted by this. The only way we can see it is through its gravitational effects. And it seems that it's there because using dark matter, we can explain a lot of the observations that we get, including rotations of spiral galaxies and gravitational lensing, the amount of lensing when one galaxy is seen through the area of a foreground galaxy. So all of those lead to the understanding that the best explanation we have right now is that there is some kind of dark matter that is not just concentrated in the galaxy, but is in a great halo around the galaxy at much greater distances, which would explain the motions of stars within the galaxy. So that was our picture of the day for June 13th of 2025. It was titled Rubin's Galaxy. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.